Okay, this is the video for the lab in which you will compare the binomial and the Poisson distributions. And what I've done, as with the previous lab, is I've went ahead and just constructed the spreadsheet that I'm expecting you to construct. And I'm just going to give you a little bit of a tour through the spreadsheet. First of all, we have our value for lambda. Now, I've been using the symbol for lambda. You can just type out lambda, or you could find the symbol in Excel. I'm sure it's in here somewhere, probably under insert. Yes. So if you go insert symbol, and I have lambda right here. If you don't have lambda right there, you'll want to find Greek letters in this list, Greek and Coptic, and there's lambda. Okay. So you can do that, or you can just use the spelled out lambda. It doesn't really matter to me. It might be that your spreadsheet software, if you're not using Microsoft Excel, doesn't easily give you that character. Anyway, you're just going to have the user enter a value for lambda. So you'll notice I've already put this to be 16, and I just sort of chose that randomly. And that's not from a formula. That's just type in a number. If you want to change lambda to 12, then we do that. We change lambda to 12. And similarly, n, that is the number of trials for your binomial distribution. That is inputted by the user. The other parameter for the binomial distribution, however, is not, and that's the p-value. And I'm not going to show you the formula for that. I want you to be able to compute that formula. And to get the p-value, just note that lambda is the expected number of times an event occurs over a time interval. Okay. Similarly, the expectation for binomial distribution is n times p. Okay. So, if we take n times p equals lambda and solve for p, we just get that to get the parameter p, we just take lambda and divide by 100, as you see that happened here. So this should just be the lambda value divided by the n value. And most of the work is going on down here. And what I've done is simulated a binomial distribution as well as a Poisson distribution, and then I've compared those with a relative error. And I've done that for each of the k values that are possible from 0 up to 100. Now if you scroll down, I've actually made this spreadsheet quite big. It goes down to 100, but then it keeps going beyond there. Okay, and that's so that I can use bigger n values, but it turns out you'll probably not use these lower rows that often. Go down to at least 5,000 rows in this particular example. I've went down to k equals 100,000. Let me get rid of that. Okay, I went down to k equals 100,000, but again, you really probably won't use these lower rows that much. So go down to at least 5,000, and if your computer will allow you to go down further, that would be great. Okay, so these are the k values. So for example, my number right here is the probability that a random variable is equal to k under a binomial distribution with these parameters. Okay. Now, we have n equals 100 and p equals 12. So, I'm going to pull up Wolfram Alpha here. This should be, well, let's see, for this probability for a binomial distribution, it's n choose k, so it would be 100 choose 0. Times 1 minus p, that would be 0.88, to the power of n minus k, that would be 100 minus 0, 100, times 0.12 p to the power of k, to the power of 0. Let's go ahead and enter that into Wolfram Alpha and make sure that that is really what this number is getting at. Okay, so I'm doing binom 100. This is 100 choose k. 100 choose 0, since k is 0, and then we had a 1 minus p value of 0.88, and we're taking that to the power of 100 minus k, and then we have 0.12 to the power of 0. Okay, and if I press enter, that's where this 2.807 times 10 to the negative 6 is coming from. Let's make sure that was really what was there. Yes, 2.807 times 10 to the negative 6. That's what that e to the negative 6 means. Now for the Poisson distribution, that only has one parameter, and that's lambda. And you may recall that the formula for the Poisson distribution is the probability of x equals k. is e to the minus lambda, lambda to the k over k factorial. So for k equals 0 and lambda equals 12, that is e to the power of minus 12 times lambda to the k, so that would be 12 to the power of 0 divided by 0 factorial. Now it turns out 0 factorial is defined as just 1. Okay, and we get an exact result of e to the negative 12, a decimal approximation of about 6.144 times 10 to the negative 6th. And sure enough, 6.144 times 10 to the negative 6. So this is computing the probability via the binomial distribution with these parameters, and this is computing the probability via the Poisson distribution with these parameters. And over here I have relative error, and this relative error is taking the difference between these two values and dividing it by the value for the Poisson distribution. And we're thinking of it as error with respect to the Poisson distribution because we're thinking of the binomial distribution as being an approximation of the Poisson distribution. Okay, now how are you going to compute this? How are you going to compute this? Well, one little trick I want to show you for these k values, folks, you do not have to go down and type 1, 2, 3, 4 all the way up to 5,000. All you have to do is type in 0. I think I typed in 1. No, I didn't. Type in 0, and then for the next cell, type in the previous cell plus 1. So here you'll see I have A5 plus 1. That gives me 1 there. And then I can just fill this down as far as I want it to go, and that will give me all the consecutive numbers. Now, how do I compute a binomial probability? For example, where did this come from? Well, we use an Excel function called binomdist, and of course that's referring to the binomial distribution. So if I use binomdist, and then in parentheses it's going to ask for the number, that's your k value. Okay, that's not n, that's your k value. N is your trials. So for this example, well, let's skip to another one. Let's go down here to k equals 6. My number is 6. That's the number that I'm trying to find the probability of. The trials is 100. Okay. The probability, that's the p-value. It's the probability of success in one trial. That's our 0.12. And then this cumulative input, that's a true-false input. It's asking you if you want the cumulative distribution or just the probability of that one number. We will always want the probability of that single number, so you're just always going to enter a false for that cumulative distribution. We're going to use cumulative distributions in this class, but we're not going to focus on them, and the term might actually never be introduced due to time constraints. Okay, so we get the 0.021516, and sure enough that matches up with exactly what's in cell B11 for the probability that x equals 6 for the binomial distribution. Now how about the Poisson distribution? Well, you can just type equals Poisson. Okay, and it's really nice that it tells you what functions are available because, you know, is it supposed to be Poisson? Is it supposed to be Poisson dist? Is it supposed to be Poisson dist? I don't know how Excel is going to encode it. Well, notice that it tells you that it's going to be Poisson. There's not an option for Poisson dist. Whereas with the binomial distribution, there's not an option for just binomial. As you're typing it, you see that you have to do binomdist. Anyway, back to Poisson. For the Poisson distribution, x is your k value. Okay, that's the value that you're finding the probability of, and we're going to do the k equals 6 example. So we'll put in 6 here. The mean of a Poisson distribution, that's the expectation, and that is 12. And the cumulative of field is going to again be false. Okay, press enter, and this returns 0.025481. 0.025481, which is what we see right here. And then for the relative error, again, you'll just take these, subtract them, and then divide by the value for the Poisson distribution. Okay, so that should be enough tools to get you going and get you set up on this spreadsheet. Please contact me if you have any problems. And for this lab, it's not only the spreadsheet. I want you to construct the spreadsheet and then also do some explorations with the spreadsheet to try to answer the questions that are in the lab's handout. So see that lab's handout for the requirements, and here I've just shown you how to construct the spreadsheet, and let me know if you need any help.